particular interest. It's, as they say, a hot field. So I'm pleased to be able to introduce Dan Ingersoll. He was here today from Oak Ridge, and he's Senior Program Manager for the Nuclear Technology Programs Office. He recently served as the Campaign Director for Grid-Appropriate Reactors within the Global Nuclear Energy Partnership, and participated in several advanced reactor programs, including the advanced, I think it's the Reactor project, which of course is a high popularity here in our department. The International Reactor Innovative and Secure Project, and Space Reactor Technology Program as well. During his 32 years at ORNL, he's led various research groups and sections dedicated to radiation transport modeling and reactor physics analysis. He received a BS degree in physics from Miami University in 1973 and a PhD in nuclear engineering from the University of Illinois in 1977. He's a fellow of the American Nuclear Society and past chairman of the ANS Radiation Protection and Shielding Division. With that, I'm going to turn things over to Dan so that we have enough time to cover both the presentation and the questions that will likely follow. And if he's okay with it, maybe even interject during the course of the talk. Dan?
I'll be happy to. And good afternoon and Ohio gozaimasu. So I'm really pleased to be here. I especially enjoyed coming to Berkeley. As Per alluded to, we've been working together for some time on the advanced high temperature reactor. It's been a great collaboration, and I'm glad I had the opportunity to come out here, especially to see the lab. Per's been sending me all kinds of presentations and video clips and stuff of the lab, so I was really pleased to be able to see it in person. So what I want to talk about today is, I think, I predict is a topic that you'll hear a lot about in the near term as we look toward the nuclear renaissance in the U.S. and the rebuilding of our nuclear industry and the growth of nuclear power in the U.S., and that is of smaller size reactors, and what I call deliberately small reactors, which I'll explain a little bit more as we go. But before I get into that, what I'd like to do is start with a little role playing. So, are any of you right now in the car? So you've already traded in your clunkers and okay. So let's suppose you are. So what do? Suppose you go down in Knoxville, we have the airport motor mile. You probably have equivalent around here. You go down to the airport motor mile, and turns out the first car lot you get to, all they have to offer is H1 Hummers. I don't know if you've seen H1 Hummers, but last time I saw a sticker, it was like 120,000. And so, you know, a little bit more of a vehicle and a little bit pricier than you're willing to put out. So fortunately, as a car buyer, you can go to your friendly neighborhood Cadillac dealer and pick up an Escalade for a lot less money. But that still may be a little outside your wallet and a little bit more of a vehicle than you're looking for. And again, as a car buyer, you have lots and lots of options, obviously. You can go out and you can get an SUV of any size. You can get a plug-in hybrid. You can get suppose you don't even want an SUV, you want a convertible, all kinds of functionalities. Or, especially for you students, you could end up with what you really wanted, which was your smart car. Okay, so let's shift gears now and suppose you're the CEO of your local utility and you're responsible for replacing an aged coal burner or perhaps there's been enough growth and demand in your area that you need to add new capacity. So what do? So you go out and first lot you come to is your friendly Arriva dealer. And they will be happy to sell you a EPR. Output somewhere around 1,600, 1,650. That's a whole lot of electricity. Nowadays, stationary power or pressurized reactor. It used to be European, and then they wanted to market in the U.S., so they made it evolutionary. This is big. The biggest plant we have operating in the U.S. today is less than just under 1,400 megawatts or so. So this is a big plant. And to the tune of, we don't know for sure how much they're going to cost, but somewhere in the $8 billion bracket. So again, maybe a little bit outside your affordability and maybe more power than you actually need. So as a CEO, you do have other options. You can go to your thing and happy to set you up with an 18 much smaller, somewhat smaller, probably cheaper, maybe in the $6 billion bracket. But again, this may be a little bit more than where do you go? Now, there actually are some other options out there on the market, but they all fit between these two here. There's some Japanese models that have 1,400, 1,500 level, but you're pretty much stuck there. That's all there is in the way of nuclear power options. So where is the smart car of nuclear power? Reality is there isn't any. Why that are beginning to realize customers need more choices, they need more affordable systems, they need systems that maybe serve different functions like process heat applications or chemical processing applications. The big plants just don't lend well to. So there's a need, and there's beginning to be a lot of interest in developing designs that meet that need. Let me start out a little bit with terminology because it actually does get kind of messy. This is the terminology that's used by the International Atomic Energy Agency. It's the terminology I use most often because it's the most precise, and it's measured just strictly by the power output of the system. So you can see that when we talk about, usually we lump the first two together and just talk about small, medium power reactors or SMRs. And just to distinguish them from the large plants, which say here is greater than 700 megawatts, but really most people think about large plants as above 1,000 megawatts. So that's kind of the distinction.
Al Gore has a category he calls very low.
Yes, very large, which is the above 1,000. So other terminology, and do ask questions or comments as we go, because that's a whole lot easier. So here's some other terms that have come up. I mentioned very appropriate reactors. That was a project element within the Global Nuclear Energy Partnership. A lot of people weren't very warm to that particular term, including myself, because